So knowing what has happened in the past is very critical just in terms of being aware of what the climate system on our planet is capable of. It's like having a rear view mirror in your car or vehicle so that you know what's behind. Well, maybe not the best analogy, but nonetheless, the climate feedback factor that we mentioned in terms of 1.3 watts per meter squared per degree centigrade, for example, uh, depends on these kind of numbers we have from the past. How has climate responded to the corresponding changes in radiation in the past that were caused by changes in the orbital parameters like the obliquity of the Earth, the ellipticity of the orbit, and something called precession, where the Earth wobbles and its orbit itself precesses because of the gravitational pull from other planets like Saturn and Jupiter. Okay, there are many ways in which we can estimate past climate warming and cooling and carbon dioxide based on chemical evidences from ice cores on ocean sediments and various other tree rings, corals, and so on and so forth. Glaciers store a lot of information. And going back here to about 65 million years ago, when the dinosaurs were just about to get whacked by a meteorite strike, the scales differ at these breaks, so we have to be careful. So there is a very short time here, millions, this is thousands of years, and this is millions of years, so be aware of that. And you can see immediately that going back to 55-60 million years ago, Paleocene, Eocene, Oligocene, Miocene, and so on, global temperature estimates say that the temperatures were much warmer than at present. Okay, this is the anomaly with respect to the base period again. Okay, here is our base period. For example, the Holocene is here, the modern period is here, and the future projected is here. I took this from a very nice paper that just came out in Nature or Science or one of these journals. I'm sure they don't mind because we are all trying to save the world. Nonetheless, you can see that there has been one spike in temperature around Paleocene, Eocene thermal maximum, as it's called, and this change to the best estimates happened over several thousand years, whereas we are going at a much faster rate now in terms of the warming over a given time period since industrial warming, revolution, for example. We don't know exactly what caused it, but there is hypotheses say something like buried methane in coastal regions would have been released suddenly and so on. Nonetheless, for various reasons like the growth of Himalayas probably, which exposed a lot of organic matter and new material, ground up rocks, etc. India collided into Asia and the Himalayas started to rise. Monsoons got formed, so weathering rates went up, and weathering removes carbon dioxide from the atmosphere. We are not going into these details, but I think you have already learned somewhere that weathering, which is CO2 dissolving into rain and carbonic acid falling on soil and rocks and so on, takes out calcium carbonate and silicate and carbon dioxide and puts it into the ocean, right? There are details which we won't go into. So probably carbon dioxide dropped. Well, we know that it dropped over these times. So over the 50 million years, we are in a kind of a cooling range, cooling regime, if you will. And you can see that there are various time scales here. The wiggles correspond to years or decades or centuries. And then in the last million or years or so, there are much slower variabilities despite the change in time scale. There was like a 41,000 year wiggle here, which corresponds to a change in obliquity of the Earth, varies between 22.5 where we are now to 24.5 and 20. Sorry, we are at 23.5 So it varies between 22.5 and 24.5 over 41,000 year time scales. Those are called Milankovitch cycles. Then it changed to this 100,000 year cycle, which is related to more to the ellipticity, but there are lots of debates about this. Something called the last interglacial, the warm period, happened here about 120,000 to 170,000 years or so, 130,000 years or so. And then the last ice age happened and we came out of it, and the Holocene remained fairly flat compared to all these other periods. The wiggles during the Holocene are much smaller. This is why we think the modern human beings basically benefited from this fairly stable climate. So then the question is, going from the pre-industrial to industrial and this rapid warming since the 1970s that we looked at, and heading into these various levels of possible warmings into the future. We will see how those projections are made. We will still be not as warm as in the past, but the big thing is here, we were not around. We only came around in the last couple of million years. So can we really manage such high temperatures? Glaciers will be gone, sea level would be very high, extreme climate events, heat waves, tropics may not be able to grow any crops anymore. Maybe Siberia will grow all the wheat, Arctic ice would disappear, and so on and so forth. So those are the questions we are facing. That's where we came from, and this is where we headed by the best of our estimates. Looking at a shorter time period for the last millennium, going back to 1000 Common Era or Anno Domini, the temperatures were below the average of 1990, and then we started warming here in the late 20th century, and this is the range where we are headed. In the best case scenario, where we reduce our emissions, we make energy efficient things, maybe we take out carbon from the atmosphere and hide it somewhere and so on, or business as usual means we don't care what is happening and we just keep living our energy intensive lifestyle, we keep burning fossil fuel, we keep increasing greenhouse gases and so on. So there is a range of about 2.5, 3 degrees to 8, 9, even 11 degrees at the far extremes. Okay, so this is in degree Fahrenheit and this is in degrees centigrade here. Sorry, I cut off the axis, but nonetheless 2 to 4.5 to 6 degrees. Okay, so those are the questions, where we came from and where we headed. The projections are made by using climate models which represent lots of things like land, ocean, vegetation, ice. Given the energy from the sun, they can produce weather, climate, monsoons, El Niños, etc. And for the future, you need to decide on the population increase, on technologies, on energy consumption, renewable energy sources, ability to take out carbon by carbon capture, and so on. And you make these estimates for the future. And we will see how the solutions try to deal with these scenarios and try to save ourselves or try to hit a global warming target like maximum of 1.5 degrees above the pre-industrial with some probability, or maximum of 2 degrees with some probability, because you can only talk about how probable is it that you're going to hit this target given all the variables. For example, when a pandemic like COVID comes, nobody worries about climate anymore, right? We are just trying to survive. Economies are struggling, so we want to kick back up the economic activity, which means a lot of restrictions on climate-related action will be ignored for a while, and so on and so forth. So there is always multiple factors to deal with. Reality always hits. So that's how you have to worry about solutions. Are they robust to survive all events, natural hazards, and so on, and still stay on goal of reducing emissions?